Have you ever met someone who is just brilliant, like book smart beyond belief, but when it comes to actually doing something practical, they just fall apart? Well, it turns out AI has had that exact same problem. Today, we're going to get into the fascinating story of how AI is finally making the leap from being just a thinker to a doer. So let's just dive right in with the big question that's been on everyone's mind. How is it possible that an AI that can explain quantum physics gets totally stumped by a problem that a toddler could solve? It seems like it makes no sense, right? Well, that is the exact puzzle we are going to unpack today. And this right here just perfectly sums up the paradox. On the one hand, you've got this AI that's a genius. It's a poet, it's a coder, it's a physicist. But then that same brilliant mind can get stuck in this bizarre, illogical loop, like trying to clean a knife it isn't even holding. Now, this isn't some weird bug. It's actually a really fundamental limit of how these models used to work. So what is this big limitation, really? Well, you can think of it as AI's major blind spot. Just imagine a giant library that has every book ever written, all the world's knowledge inside. But it's a sealed room. No doors, no windows, and definitely no hands. It can't reach out and check anything new. And that's pretty much what early large language models were like. They're kind of like a brilliant brain in a jar. They're trained on this huge snapshot of the internet, so they know a ton. But if that info is outdated or just plain wrong, they have no way to check it. They can't interact with the world. And this leads to a huge problem that you've probably heard of, hallucination, where the AI just confidently makes stuff up. And check this out. When researchers really dug into why these AIs, even ones using a think step-by-step method, were failing, they found something pretty shocking. Hallucination, just making things up, was the #1 reason for failure. We're talking over half of all the errors. The AI was basically just guessing because it had no connection to real-time, factual information. So, to fix this, researchers knew they had to give that brain in a jar some hands. They needed to let it break out and actually interact with the world. And this is where a really game-changing idea called React comes into the picture. It's the first huge step from just thinking to thinking and doing. The whole idea behind React is that it gets the AI out of just talking to itself. Instead of only thinking about a plan, it can now act on that plan using tools like a search engine. It's like we finally gave that library a phone and a computer. Now it can actually look things up. And it works in this really clever little loop. First, there's a thought. The AI makes a plan. Then it takes an action, like searching Wikipedia. It gets back an observation, new info from the real world, and based on that new info, it has another thought, updating its plan. Thought, action, observation, thought. It just keeps going, learning and doing in a cycle. Let's make this super clear with an example. An older AI, when asked what two directors have in common, just kind of guesses based on its internal knowledge. But a React agent, it's completely different. It thinks, okay, first I need to find out what these guys actually do. Then it acts, it searches for Nicholas Ray. It observes the result. Then it acts again, searching for Elia Kazan. It's building its answer on facts it's actively finding, which makes it way, way more reliable. Okay, so giving the AI hands and tools was a huge deal, but what happens when its plan is just wrong? What if it tries an action and fails? A React agent can get stuck, just trying the same failed move over and over. It can act, sure, but it can't really learn from its own mistakes. And this is the next massive hurdle to clear. If we want AI to be truly capable, we can't have a human babysitting it, correcting every little mistake. It needs its own internal voice, a way to look at what it did wrong and figure out how to do better next time, all by itself. And the solution is an absolutely brilliant concept called reflection. You could almost think of it like the AI is coaching itself. Instead of just getting a "you failed" message, the AI stops and literally writes out why it thinks it failed. It creates this little memory, this little nugget of wisdom that it uses to make a much smarter plan for the next try. And here's what that self-coaching actually looks like. It's amazing. After a failed task, the AI generates this little reflection. It diagnoses its own mistake, I incorrectly assumed, and then comes up with a new game plan. I should focus on better researching. It's not just guessing again, it's learning a specific, concrete lesson. So you might be asking, does this actually work? Oh yeah, the results are just staggering. In this complex simulation, an agent with just React succeeded about 71% of the time. Not bad, right? But look what happens when you add reflection, the ability to self-correct.
the success rate just skyrockets to 97%. That is a monumental difference. Learning from your own failures is clearly a superpower. All right, theory is great, but let's see this thing in action. We're going to walk through a really simple task to see how these different AI agents actually think and behave when they're put to the test. So the task is dead simple. Put a clean knife in the countertop. Easy enough for us, right? You find a knife, you walk it to the sink, you wash it, you put it on the counter. A few logical steps. So let's see how the AI handles it. Now, just look at this. The first agent, the one that can only act, starts off okay. It grabs the knife, so far so good. But then it tries to clean the knife while it's standing at a countertop on the other side of the room. Obviously, that fails. So what does it do? It goes to another countertop and tries to clean the knife with the sink again. It's completely stuck in this bizarre, nonsensical loop. So what's going on here? It's simple, really. The agent has no common sense understanding of the physical world. It doesn't get that to use the sink, you have to go to the sink first. It knows the words, but it doesn't understand the necessary sequence of actions. But now, let's bring in our agent with the self-reflection superpower. The moment it fails for the first time, the moment it tries to clean the knife from across the room, the whole process pauses, and the agent is asked to think, okay, what just went wrong? And this is where the magic happens. It generates a thought just like this. It correctly figures out the problem. I tried to clean the knife before going to the sink. And then it creates a brand new, correct plan for its next try. It literally learned from its mistake. And on its very next attempt, it's flawless. It follows the new plan perfectly. It gets the knife, it goes to the sink, then it cleans the knife, and it finishes the job. That's the difference between an AI that's just following a script and an agent that can actually reason, adapt, and learn on the fly. So you see, this isn't just some small incremental improvement. This combination of thinking, acting, and reflecting, it's a fundamental shift. It's really the birth of what we can finally call a truly capable agent, an AI that can start to handle the messy, unpredictable real world. And what this means for all of us, well, it's huge. It means more reliable AI that doesn't just get stuck on simple things. It's the foundation for AIs that can take on really complex, multi-step problems. And here's something that's incredibly important. It makes AI easier to understand. We can actually read its self-reflections to see its thought process. That's a massive leap for making AI safer and for working together with it. So we'll leave you with this final thought. We watched AI go from being a closed-off library of facts to an agent that can use tools to one that can actually coach itself to get better. So the real question now is, what's next? What kind of problems we thought were impossible, could we finally solve with an AI that can't just think, but can act and, most importantly, can truly learn?